Welcome to qnawire.
Hi, so over here, before answering the question, let's do a reminder on zero order and first order reaction. So for a zero order reaction, the rate is going to be given by, zero order. We're going to know that the concentration of a certain species as a function of time is going to be equal to the initial concentration minus kT. For a first order process, what is going to happen is that that same concentration is going to decay in an exponential fashion. And often we see this linearized as logarithm of the concentration as a function of time is equal to the logarithm of the initial concentration minus kT. So in this case, the shape of the graph of concentration versus time, in the first one is going to be a straight line with a slope equal to minus k. And for the first order reaction, what we're going to see is that the concentration is going to decay in an exponential fashion. So in this case, for graph B, the process would be a first order, could be a first order rate process, but just to ensure what is going to happen on the next scenario, for a second order process, what we're going to get is that 1 over the concentration as a function of time would be equal to 1 over the initial concentration plus k times t. In this case, if we graph concentration versus time in the second order process, what is going to happen is that the shape is going to be very similar to the exponential decay. So in this case, without having any extra information, this could correspond to a first or a second order rate process. In order to differentiate them, we would need to have the graph of the logarithm of the concentration versus time and the graph corresponding to 1 over concentration over time. So if over here we see a straight line, then this would be a first order. And if we see something like this on the plot of 1 over concentration with respect to time, then it would be a second order process. But since we don't have any extra information, the correct answer would be a first or a second order rate process.